Very warm welcome to all our attendees for this webinar. I'm Pankaj Bagzai, Senior Manager of Marketing with Impetus Technologies. Thank you all for joining us today. We are now starting our webinar for planning a successful enterprise data warehouse to Hadoop migration. Now, most of us have witnessed the open source Hadoop distributions maturing in 2015, leading to Hadoop being seen as the replacement for long successful data warehouse solutions that use SQL and PL-SQL. We have been also seeing an increasing number of workloads and data being migrated from the enterprise data warehouse to Hadoop-based big data stores. However, with complex data models and code written for the EDW environment over many years, the migration is certainly very challenging. Our webinar for today from the Impetus team is aiming to see how offloading workloads from traditional Teradata, Netezza, Oracle, MySQL, SQL Server-based warehouses to Hadoop is being solved at many large enterprises. Now, without further delay, before I invite Vineet, let's have a quick look at the agenda for today's session. We will be looking at why migrating the workloads to Hadoop is increasingly gaining significance in the enterprise. What are the challenges that enterprises are facing while migrating the workloads, and also introduce you to what we call the 4-click paradigm that comprises of connect, assess, migrate, and validate. So without further ado, let me invite Vineet. Vineet, over to you.
Thank you, Pankaj, and a very warm welcome to all of you who are joining our webinar today from all over the world. I'm seeing on the WebEx that we are already close to 150 people, so thank you very much for all of you for joining. I'm sure this topic is of interest to you, so that's why you have joined. What we present to you today is based on learnings that we've had working with customers, large enterprises, Fortune 100, 500 customers that we have been working with since the last 9 years. So hopefully you will find this material that we're going to be presenting useful for the topic that we chose to present on today. And before I move on and start conversing about the topic, I was recently at the Gartner BI Summit, where Gartner presented their annual BI results of their annual BI survey. And, they poll upwards of 10,000 of small, medium enterprises as well as large enterprises for different aspects of their BI investments and how they are working. What was surprising from the statistical point of view was that they made a very strong statement which says that enterprises today are only realizing 15 cents to the dollar they're spending on the potential BI investment. So basically, for every dollar that is being invested into BI, we're only realizing 15-cent worth of ROI. And that is becoming a challenge. Not many customers and large enterprise customers that we work with are continuously striving to have a much better ROI. 85 cents that are still potentially up there need to be realized back, and they're looking for ways to increase this ROI. And what we've realized with working with our customers, that big data is forming a large part of that increase of ROI kind of a strategy. So working with our customers, what we've seen is that they have been in various stages of preparation and various stages of where they are on their journey of rolling out the big data, strategies, etc. 20, 25 large enterprises that I personally worked with, I'd like to categorize, and we've come to categorize them into a kind of a maturity model that demonstrates or denotes 4 levels of rollout, and which is primarily around, at one level, enterprises are looking for handling and ingesting data at scale. So they bring in Hadoop and big data technologies into the ecosystem, and they try to ingest data at scale. They build capability that allows them to have an active archive kind of a capacity at a much cheaper cost. And once they've mastered that, they start building the analytical muscle, laying foundational plumbing of moving data in the enterprise, in and out of the data lake, from generating insights and then taking the insights out to the BI layer and then serving that out, etc. Then, the third level of customers that we've seen is that where, all of this comes together and it starts getting interoperated with the enterprise data warehouse assets and the data marts that exist. And at the pinnacle of, all of this is the logical warehouse architecture where all the data assets within the organization are available and working in unison, irrespective of where the data might be stored. So on this maturity model paradigm, we've seen a lot of our customers in the variety of different places. We also have Venkat, with us, and Venkat has been working on the field with a lot of our customers, talking to a lot of people. So I'd like to invite Venkat to talk about, why, customers are working with us and why they're choosing to migrate the workloads.
Thank you, Vinit. During our journey working with the clients and prospect across all industry, most of them are somewhere between level 1 and 3. Typically, it is all driven by who is heading the big data opportunity within the enterprise. If it is driven by the business with data scientists and power users, they are somewhere between level 1 and 2. They bring in new content and trying to solve some particular things. If it is driven mostly by the technology groups, then they are almost close to level 2, and they are putting the process in place so that it can be sustained. What we are also seeing is when these two identities work together, then they are getting closer to level 3. They have use cases that are sustainable and are able to get measurable ROI. Level 4 in general is a goal that many want to get to, but I have seen very few already there. So why are people migrating workloads to Hadoop? As Vinit was saying, the cost of doing business in traditional EDW is getting higher and higher, and the returns are becoming lower and lower. Most of the customers want to control their expenses, as well CapEx as well as operational expenses. So by creating this multi-environment, data warehouse environment, is what most of the customers we are seeing in the market are moving towards, because it helps them not to lose existing functionality, but to add new functionalities at a much more cheaper rate. So the goal here is to have an ecosystem that they are comfortable with their traditional RDBMS, and also bringing in new technology that is increasing their functionality. What we are seeing, both with customers as well as with prospects, is this type of an environment is better suited for today's advanced analytics, and they are set up for success.
Great. Thank you, Venkat. Great insights. Now, we'd quickly like to poll our audience today for what is your primary motivation when choosing to migrate workloads to Hadoop? You can see the poll on your screen right now. You have options to choose for what is your primary motivation when choosing to migrate. The options are freeing up your capacity to contain costs. The second option is create a multi-platform data warehouse environment. And the third is to create an ecosystem better suited to advanced analytics. We will be expecting your replies. The poll is up on your screen now, and we will be giving you about 30 more seconds to respond. We really appreciate the people who have already responded. We will be sharing the poll results after collating the online responses right now. I'm seeing about 60 people have already responded. A few more, many more people to respond. Please, 10 more seconds to go. So, okay, the results are in and collating the results now. Okay, I see about close to 70%, to be precise, 67% want to create an ecosystem that's better suited to advanced analytics. That's very interesting. The other two are about 20% each, the first two options. So thank you, audience, for responding to the poll question. We'll move ahead and Venkat, back to you.
Okay. So what the industry is doing is they are trying to migrate. There are a lot of efforts that is going on manually migrating this and moving it into the big data environment so that they could create, as all of you have rightfully selected, create a better ecosystem that will satisfy today's analytical needs. But there are a lot of challenges. It is very expensive because some of these things are already existing in an environment. To move them over, there is there are challenges because it has been there for a long period of time, and we have to now migrate it and not lose any functionality. Things have to be debugged because it doesn't work direct as is on the new platform. And also the validations to make sure that everything is working is getting tougher and tougher because we have to do this at a very short period of time, whereas the existing environment has matured over a long period of time. So what are the basic challenges that we are facing within this environment? The manual process is highly complicated. First thing is, are we able to once we have identified a workload, are we able to identify every object within that workload that needs to be migrated? That includes what are the tables, what are the views, the data, dependent queries, stored procedures, macros, shell script, and depending some of those procedural stuff that is done outside the RDBMS. All of these things have to be identified and be brought into scope. Now, once that is done, how does the schema get migrated from the existing environment to the new environment? It's not a straight one-to-one translation. Not all the functionalities that are supported in relational environment is mature enough in the Hadoop environment. As well as now moving the historical data and the relevant logic behind it, all of those things to be migrated, it is taking them time. So think about any small workloads or big workloads could take anywhere from 6 to 12 months, and if they have done all this prior stuff very diligently, it could take them this much time to do it. But at the end of the day, they are not giving any new things to the end user because these are already existing in the RDBMS. Yes, it cannot scale, but they are already existing. So they're also facing a lot of technology challenges, like the same things that are working, sophisticated SQL procedures and things that are working in relational, it is not working on the Hadoop side. You have to do workaround or split them into multiple steps for them to be able to get into the next things. The keywords are very specific to the relational tables that are not yet supported in Hadoop. Don't get me wrong, the open source is working to get to that point, but it is not there. There are a lot of gaps in today's environment. So bottom line is you're spending a lot of money, time, and effort, but you are not guaranteeing the end results are going to be exactly meeting the same SLAs as what was there prior, and the users are not getting happy because they are losing some of their functionalities and they are being transferred to a new environment. At the end of the day, users want information. They do not really care where they are getting that information from.
Great. Thank you, Venkat. Now we are at a stage for polling our audience again. This is our second and last poll for this session. We'd like to know from our audience today what you see on your screen. The poll says, what are the challenges that you are facing in migrating workloads to Hadoop? You can choose one or more options that apply. The options on your screen showing right now are it's difficult to manually identify the workloads to migrate. The second option is not sure about the data model on Hadoop, or you see a manual process risk, which is time-consuming and error-prone. And the fourth option is no support for traditional data warehouse or relational technologies like SQL. So we'll be expecting our audience to respond. I see about 70 responses already coming in and about 20 more seconds to go. I really encourage our audience to respond and see where the industry is and what their challenges are. Please respond to the poll. Last 15 seconds going now. And just would like to remind our audience, along with this poll, please feel free to send in your questions using the chat and the Q&A panel during the course of the presentation, and we'll be taking most of them towards the end or as appropriate when the panelist is discussing a particular slide. So the results are now coming in. We'll just give it a few more seconds to get collated. We've seen about 110 people have finally responded. And interestingly, about 61% of our audience is not sure about the data model on Hadoop, and that's their primary or top challenge, followed by the manual process risk and no support for traditional data warehouse or SQL-like technologies. So thank you, audience, for responding. We are now moving to the next part of our webinar. Vineet, over to you. Thank you.
Sure, thanks, Pankaj. And so these challenges are what they are, and it's interesting that all of you are migrating workloads and trying to use big data and Hadoop specifically to increase the ROI. So what is the framework that we've laid out for being successful with our migration projects? I think what we have is basically 3 keys to unlocking this success. Any successful migration that we've seen on the big data side is that you need to have the assessment done in a very scientific fashion. It has to be a data-driven decision based on analysis of what is working on the enterprise data warehouse, how it is working, and what actually is the best thing to be taken off, offloaded, and taken onto Hadoop. So there are several considerations that will end up deciding, technology match, what is the best data model, what is colder sets of data, what is lesser risk-free, and many other considerations that help you figure out what is the right workload to be taken to Hadoop. So I think the number one successful thing that lays the foundation for everything is that the assessment doesn't have to be intuition driven, that we feel that let's do this. Rather, it should be a data-driven decision in itself that defines what should be offloaded. The second is an automated migration. So basically, as Venkat was talking about earlier, manual migrations are very risky. You are as good as the best person in the team. And we all know, running IT teams, that Hadoop skill sets are very rare to come by, and also people with real life experiences are even rarer. So how do we move away from the risky human intervention? So automation is the key there. Can we have a best practice driven framework that can repeatedly apply the best practices in migration rather than doing the migration through human intervention? And the last is automated validation. And that's even more critical than anything else, because what we've seen working with our customers is that if we spend 100 effort hours in migration, it generally takes upwards of 100 to 150 hours in validating what has been migrated, both the functional validation as well as the validation on the equivalence and the data integrity side as well. So because you are going from a RDBMS to a big data-driven Hadoop model where you could be flattening your data store, your data structures, your joins could be working differently. There has to be a lot more validation to establish the functional equivalence. And if you're not having a automated validation strategy, it's going to be a time-consuming and a very risky proposition to convince and certify that certain workloads have been successfully migrated. So we have been at Impetus working with big data for almost, and with Hadoop for almost 9 years now. Even before some of the distributions were incorporated, we have been working on experimental basis with the versions of Hadoop. And based on our experience of having put 25 plus enterprise customers in production with a variety of different use cases, we've seen these repeatable problems, and we've created a framework that we call the 4-click paradigm. I would like to spend some time taking you all through some of that. Unfortunately, we don't have time for a demo, but I like towards the end do a software demo where I'll be sharing some screenshots of how our solution works. So let me jump right into it and introduce you to the 4-click paradigm. The 4-click paradigm that's built on proven best practices and learnings that we've had is basically 4 stages: connect, assess, migrate, and validate. Each of these stages is automated, fully automated, and we've created learning engines to power the automation such that all the best practices and learnings that we have can be repeatedly applied through the tooling on the migration projects. So what is the connect paradigm all about? So what we've seen is that most of the enterprise customers do not have one kind of a so to say technology stack there. So there is different types of. We've seen at least every enterprise has 2 or 3 of these database technologies that are powering their different versions of warehouses or marts or ODSs as well. So what you need is a capability, an automated capability to be able to connect to different sources, etc. And what our tooling and our solution, Impetus tooling makes available is that there is an automated way to be able to connect to any of these supported data warehouses. So we currently support Teradata, Oracle, Netezza, SQL Server, DB2, and there are many more in roadmap that we'll be able to connect in the future. And once we are able to connect, we then are able to do a full assessment, a fully intelligent assessment and identification of offloadable entities. So once we are able to connect to any of these warehouses, we read the query logs and we read the query information and other things. And then we are able to analyze and recommend what workloads, queries, data, and tables are there which could be offloaded. And we also saw that during the poll, one of the largest consideration that is there, or the biggest challenge that everyone is facing, 61% of the people said they're not sure of the data model. So in our analysis, what we also determined by looking at the queries is what is the query engine and what is the data model which is appropriate for these queries to be migrated to such that you can meet the SLAs. And how we determine the SLAs is by looking at the historical log information and the query extract log where the queries have been running, and over the past 3 months or 4 months, what is the average time every query has taken So that gets converted into the SLA, and based on that intelligence, we are able to then recommend the right data store. Should you be running these on the Hive store, or should you be running them on Spark? Or in future, we are also going to be able to support Phoenix over Edge-based. So, what is the recommended data store is what we also end up suggesting. So it's a fully intelligent assessment that lays the foundation and makes it a fully data-driven decision of how and what to offload. Now, when it comes to migration, which is the next step, what we end up doing there is that we built a migration tool, which actually parses any SQL, extended SQL, which means PL-SQL or Netezza PL-SQL, or if there are, Teradata BTQ scripts or Oracle extensions. And we are able to parse them, and we are able to then forward migrate them to a Hive query, which includes flattening the data model, which includes the optimizations in the data model. So all the data migration based on the model transformation is taken care of. So all the recommendations for partitioning, clustering, bucketing. We also migrate the role-based security if it can be applied onto the Hadoop-based data store. We also have capacity and capability to do that migration. Plus, all of this is fully validatable. So there is inbuilt validation checks which allow us to do checksum-based, count-based, counting the number of nulls, distinct values, averages, min-max, and through multiple of such checks, we are able to certify that the integrity of the data that has been migrated is remaining the same. So we certify that integrity through these inbuilt data validation tools. Not only that, in a future release, we'll also be able to support user enforceable. So users can write certain queries or upload certain programs which will be used for validating the data sets. There are other machine learning driven, random sampling basis, checks that we are also building. Then comes the workload transformation part. So, as Venkat was talking about earlier, one of the bigger challenges is that Hadoop technology stack sometimes is not mature enough and doesn't support. For example, Hive doesn't support ANSI 2012 standard yet. So you do not have a functional equivalence, or you do not have keyword equivalence for a lot of the queries that are running today successfully in the warehouses. So how do you deal with that? So we've created a large degree of a UDF library to support some of these keywords and other elements which are not supported natively on Hive and other data stores. We've also, have a learning engine, which is a pattern-driven engine, in which we have incorporated all the patterns of how and learnings of, how to handle different types of queries and how they will be, best working in a Hive or a Spark SQL. Then we also have so this is a fully automated SQL and PL-SQL conversion that we have. Then we also have an execution engine. Lot many times, and at level 3, when there is a lot of data, in some cases our customers are using Hadoop in a pattern where it is a data refinery. So basically, all the data preparation, etc., has been offloaded to Hadoop, and all the prepared data sets go back into the data warehouses for consumption. So in that case, we also support the workload execution across different type of engines, and then we also have the ability to schedule and move data back and forth between different type of data sets as well. So the last step in our 4-click paradigm is the validation, and that's the more critical step. Because there is model transformation, because there is code transformation that's happening, there is a lot of validation, automated validation that we have built in our framework that establishes functional equivalence. And what that means is, because the code is not one-to-one equivalent. What we have to make sure is that whatever the code was doing on your existing, warehouse appliance, it does the same thing on the data in Hadoop. So how do we establish that? We do script-based checking, we do random samples, input-output checks, etc., and that allows us to certify that and establish functional equivalence. The other thing is around meeting and doing performance certification, where we meet or exceed the SLAs. So we have an intelligent assessment engine which determines which is the best query engine where we should be running. So we have support for HiveQL and Spark SQL. So we determine wherever is the best query engine, we transform the query and allow those kind of queries to be generated. We have support for Hive on Pace, Hive on Spark engine. There's built-in recommendations. There is optimization of parallelism. And because Hadoop itself provides us a lot of scale out on commodity hardware, SLAs, meeting the SLAs becomes a price performance kind of a trade-off, where if we have to meet a certain SLAs, we can scale out, increase the number of nodes, and we'll be able to meet that at a certain price. Now moving on, as I promised you that I'll be giving you a soft demo, kind of a mock demo through the slides today about how our solution works. So, and in case if you are interested about seeing our demo, we are offering you that we will be you can reach out to us after the webinar, and we'll schedule a one-on-one demo for you to take you through in live detail about how our solution works. So here is how our solution looks like, and when we go in, we can do an assessment, and we can do the assessment in two ways. Either you can give us the SQL scripts, or you can give us an extract of the query logs, or we can directly connect to one of the warehouses, and we can pick these things up by ourselves. So this is showing where either you upload the query logs and the SQL scripts, or you can go in and directly connect. So once we have this information available to us, there are different tolerances or configuration based on which we do the assessment. So consider them these to be the softer parameters on which we will be doing our analysis. So performance tolerance means that do you want the same SLAs, or can you live with 70% of the SLA on Hadoop? If something was taking, let's say, 10 minutes on, or let's say 10 seconds, can you live with 70% of that SLA, and so on and so forth. Transformation capability, risk tolerance. We also do a notional cost calculation using a cost to run number that you can configure here. And based on these, you can also save this as a template for repeatedly doing the assessment. And what you're seeing now is a dashboard that once our engine runs the assessment, it starts showing you a summary information. You can see there it shows information about the queries, the tables that are analyzed, query categories, query constructs. It has certain recommendations that it has found. So what you're seeing here is that it analyzed about 866 queries, 593 were successfully analyzed, and 273 were not applicable, because a lot of times there are queries which are subqueries or temporary tables, and queries which are just created for if then else kind of conditions. So it disregards those kind of queries as secondary and then does the analysis. It can keep drilling down. So in the analysis, you have full data now. So full data is available to you. What it is showing here is that all the queries that it analyzed, and it will be able to tell you why and what was successfully analyzed and what was not. Then based on the tables, it tells you which tables were analyzed and which queries were working on which tables and what data was getting accessed and all those attribute information. You can drill down into each of the query and each of the query categories and get more details around that. How many types of select, how many types of insert, etc. So there's a lot more deeper data that is available, and each one of them, this functionality has a much richer detail than I can show in this screenshot behind it. And all of this leads to the recommendations where we have identified offloadable queries, offloadable tables. And then it shows that if you offload some of these things, how much CPU will you save, how much storage will you save, and some of the other things. Other statistics that we've gathered, and you can drill down into. It is also showing the CPU usage by queries, etc. More details around offloadable tables that the queries use. And this is the intelligent assessment. So the other part where we have lots of intelligence is in suggesting which of the queries can run on which of the engines, right? And it does that analysis, and it tells you that this query, if you transform through our tool, we will be able to run on Hive, we'll be run on Spark SQL as well as Phoenix. So it has all these intelligence built in, and a lot of recommendations that are available. And all of this can form the basis of a very intelligent assessment, and you can repeatedly keep doing this. There is no cost to every run. So this is in the tool. It's very simple. Doesn't take a lot of computing power. You can run it with different perspectives over a 2-month period, over a 4-month period analysis, and it will give you a lot of insights about how to set up your migration project. Now next comes the actual migration, the magic that where we automate all of these migrations and the code conversion. So basically it's based on a pipeline, and it's a visual designer where I can set up pipelines. As you can see here, I'm connecting to a Teradata source, then I'm migrating the data and doing some transformation, which is in the third node. And then I'm doing some, execution, and I'm doing some validation, etc. So based on all of these things, it will be able to migrate any of the scripts, etc. And once you can see that, it identifies tables, etc., and you can map the model based on which you are going to do the migration. There's certain optimizations that are also built in, so you can say what partition, where to cluster, which column to cluster on, etc. And based on that, then you actually do the migration, and you can also schedule the execution as well. So here I'm seeing a report of the successful migration, and you can see that these actual queries in the live demo, you can actually see, we would be able to show you what was the original query and what the tool has transformed it into. It tells you that did it apply any UDF, or did it do a functional transformation, or was it a manual transformation needed. Some of the time it indicates the tool doesn't have a pattern, so it will spit out an error, a user identified by error that gives you enough information as to why the transformation is not working. And based on that, then you can take some manual corrective actions as well. There's full reporting and analysis available on all these migration, monitoring of all these pipelines, partially running them to a certain stage. So towards the end, what our framework allows you to do is basically what we've seen, and we have demonstrated this value across some large enterprises that we're working with. That you don't have to spin up 50 people team, you don't have to invest $2 million in a year-long program to do the migration. We could migrate workloads in days and weeks. So instead of taking months and years and millions of dollars, we are doing it in days and weeks. It's risk-free because it's automated. We are getting anywhere up to 80% out-of-the-box automated conversion. And for the remaining things, it's a learning engine, so we can recognize, our team can recognize the pattern, build that back into the learning engine, and have the ability to almost reach very high degree of automation. We do not have any lock-in. All the code that gets generated is 100% MySQL or a Spark SQL or a Java code. So there is you do not need the tool or a runtime. So you're not locked in. It's a pure migration to native Hadoop code. So with that, we come to the end of this webinar, and over to you, Pankaj.
Thank you, Vineet. Great insights. Thank you, Vineet and Venkat. Now, We are at the Q&A part of this webinar session. We've already started receiving some questions that I have here. Vineet and Venkat, you can see them listed. I'll quickly read out a couple, and I encourage our other audience members to send in your questions using the chat or the Q&A panel. The first question is probably Venkat can take it. One of our members wants to know, is your research factoring the savings from licensing costs associated with the traditional BI approaches, and also what percentage is the savings from the licensing amount?
Thank you, Pankaj. It depends on the type of license you have and the database that you are currently using. What we are talking here about is the licensing cost that is related to your RDBMS. We are not replacing any of your BI tools. Now, at this point of time, we are trying to say that we will replace your ETL tools. We may be able to offload some of the workloads out of the ETL tools. That way you are reducing the footprint on the ETL, and it depends on how much of that we want to do it. And as we said initially, this is not a big bang approach. It will be more on a workload by workload stuff. So typically what we have seen is as you start reducing the percentage of your dependency on the RDBMS, starting with 10% to 20% to all the way up to, as you mature and mature, you go up, you're reducing your RDBMS licensing cost. It could run anywhere from 20 to 50% of that, and eventually, depending upon where you end up, you are going to have a shorter footprint. More than that, there are also savings on the hardware side. Now that you have released capacity out of your existing enterprise environment, that is, you are not going to be doing refreshes and things like that, and this could run for, depending upon the size of your footprint, could run into millions of dollars, because as you start reducing it, instead of doing a refresh next year, you would take another extra year. And as you are moving things away from your EDW, the refresh may go longer and longer, and you don't have to be buying new capacity.
Great. Thank you, Venkat. So we're getting a lot more questions, and probably we'll have to extend the session by a couple more minutes to answer the questions. Second is, what are the data model challenges, considerations when it comes to migration from the OLAP data warehouse to Hadoop?
Sure. So there's a lot of I would say science and black art behind this that is both tied together. So data model challenges, what are, so we are basically moving from a RDBMS and entity model-driven, paradigm where full SQL is supported, to a paradigm where, you are actually flattening the data, and you're actually flattening it for the purpose of doing distributed processing to speed up, right? So you're not basically trying to join data as much as you do in the RDBMS world, and that's the biggest difference that we see. So these data model challenges, we can have a whole new webinar around that. But we do have a nice report written about some of these challenges, and Pankaj, we can make a note. Whoever asked this question, we can share this detailed, technology considerations with the person. I think I can start listing all of them together, but it will take a large amount of time. So in the interest of time, we will definitely respond with more details from whoever asked this question.
Sure, Vineet. Thank you. I'll make a note of that. We'll move on to the next question in the interest of time. Somebody wants to know, why not use Talent for migration instead of the tool that we showed? Why another tool? What is the value that we are providing, and is the target persistent product always high?
That's a good question, Pankaj, and I think our audience is asking the right question. So yes, you can use Talend for migration, but only for data migration. What we offer is way beyond data migration. So you see the workloads typically involve not only data, historical data, but all the code base, the logic, the SQL, and other things that have been created. Now, and a lot of times that is in database. It's not in tools like Talend. So Talend and other DI tools and data blending tools can be used to migrate the data off from a data warehouse into a new source or maybe Hadoop. But what about all the logic that was working on the data, all the queries, etc.? Talend doesn't have capabilities to migrate that. Our tool actually does the transformation and fully lift and drops. Basically, you can lift and drop the workload onto Hadoop, including all the logic and packaging and everything together. So that's the biggest differentiation that our tool will provide.
Thank you, Vineet. The next question is, there were over 200 failed queries in the analysis slide, in the assessment part that we demoed. Does the report also identify why they failed?
Oh yes, absolutely. So there's a full, like I said that I don't have in the slide demo. There's a lot more details that we can show in the live demo. So absolutely, the report identifies the reason why those queries were not analyzed, or what was the specific area, what was the specific error, etc. So it provides all those level of details that can be understood and presented down from the up from the executive down to a practitioner level. So it provides all level of detail information.
Great, thank you. Next question is, does the tool extract only metadata from the data warehouses, or does it access the data also? And also, does it expect access to just the database or the ETL reporting tools also? Venkat, can you take that one?
Good. Okay. So what I was saying was, as Vineet was saying, we not only do the schema migration, which is the metadata migration, we also do the actual data, the logic behind the data of whether it is consuming the data or injecting the data into the tables. All of that is being done. From an ETL perspective, we do have some support for XML. Whatever SQL is embedded inside the XML, we can take that out and convert those two. From a reporting perspective, if it is SQL written reports, they can be converted from, which is what the consumption aspect of it will work out to be. We can go, as we move through the individual demos, we can actually showcase all of these things in much more detail.
Okay, thank you. I think we already ran 7 minutes past the scheduled time. There are many more questions. I'll quickly read out some of them, and we'll be answering those questions through email. So some of the other questions are, what is the performance like when using Hadoop as a warehouse, and the volume is about over 1 billion records per terabyte? Another one is this Impetus tool to connect, or is it native to the RDBMS? Of course, it is not native to RDBMS. It's an Impetus built tool. Another one is the trend moving towards Spark, and has it got better computing platform? Is it a better computing platform from a performance and analytics perspective? I think we handled the next one. The other one is, please share a list of what reporting tools or ETL tools does this framework have connectors to, apart from the databases that were shared. And many more. I see many more questions coming in still, but unfortunately we have ran out of time. We thank once again to all the members who have joined us today, all audience members who have joined us today. We've also opened a feedback poll on your WebEx screen right now. I request that you respond with your experience from today's session. We appreciate your feedback and any comments that you would like to provide for today's session. We appreciate your feedback and joining us today. Thank you very much. Have a great day.